Let's take a look at basic graphing on a TI-Nspire calculator. Now this is a little bit different than yours. Your display, of course, will be on top here, but you get the idea. You may be at different places on your calculator, so if you press the on, that'll set you back to here. Now, the first one we're going to take a look at is y is equal to x. Now, we're learning the basic building blocks here. You may already know what y is equal to x looks like. Most people do. That's not the goal here. The goal is to learn how to do these basic building blocks on our calculator so that then later on we can combine them together to make more complex graphs. Okay, so let's graph this. Now, again, if you press on, that'll get back to here. And you can use the up arrow and down arrow to choose whichever one. You can also use, I think, touch, but I didn't have much luck with that myself, so I'll use these. So anyway, I got graph highlighted, so I'll go ahead and press enter. And I'll come here. Now if you press tab, that'll go bring up your window where you can type in your function. And you see it's sitting there, f1 of x is equal to, so it's waiting us to put a variable in, so I'll put x in, and then I'll press enter. And that's our graph. Okay, let's say yours doesn't look quite like that. Maybe the zoom is screwed up. Well, if I press menu, then you see we got actions, view, graph, window, zoom. Let's go down to window zoom, and I'll press the right arrow key. And we want to choose the fifth one, I guess. Well, that's kind of weird. They changed that. Most TI calculators, it's a sixth one. But we want to choose zoom standard. So I down arrow to it and press enter on it. Or you can just press the numbers in front of it. Press the 5, it does the down arrow and enter for you. And that sets you back to your standard viewing window. We didn't see any kind of change here, but standard viewing window is -10 to +10 usually on your x-axis. And normally it's -10 to 10 on your y-axis, but you see we got less real estate here, I guess. So it's going from -6.43 to +6.43. But that's our standard viewing window. Now, one thing I do want to point out here, because I put some extra garbage on my graph earlier today, and I couldn't figure out how to get it cleaned off, so I finally figured it out. If you press the menu, you see the first one that says actions. If you press your right arrow key, and you see the one that says delete all, that kind of cleans it all out for you so you can start over. So you can either press 4 to choose it, or you can down arrow to it and press enter on it. It says, are you sure you wanted to delete everything? Yes is already highlighted, so I'll press enter. And cleans it out. Anyway, to enter in our next one, we're going to take a look at y is equal to x squared. I'll press my tab, go back to here, and then I want to do x squared. So I do my x key, and we have a x squared button here, so push that, and then I'll push enter. And that gives us our graph. Let's take a look at how to do y is equal to x to the third. And what I'm demonstrating here is how do you do it when you have any number up in your exponent. X to the third, x to the fourth, x to the fifth, x to the 20th, whatever. Well, I can press tab to go back, but when I do that, it goes down to F2, so I have to press my up arrow to go back to F1. And I can press my delete to clean those out. So I'm going to do my X key. Now I'll do my caret. Caret is how you do exponent. And notice that actually throws it up in exponent mode right up there. And then I'll put 3 in. To get it out of exponent mode, you press your right arrow key. And that'll get it out of exponent mode. That'll become important later on when you have more to put in after the x to the third. And then if you press enter, it'll grab it. And that's what it looked like. What do I mean more after it? Well, if I press tab, go back to here, and I do my up arrow. Let me press delete to clean that out. There we go. Let's say I want to graph x to the third minus x squared plus 1. So I'll do my X key, caret, 3, right arrow, I forget what I said, let's say minus x squared. So minus x and then my x squared, and then plus 1, something like that, and press enter. Then we get this. Well, if I hadn't done the right arrow key, let me go back to tab, up arrow, and delete to clean those all out. If I'd done x key, caret, 3, plus x squared, plus 1. Notice everything is up in my exponent. And then when I pressed enter, oh, that's pretty bizarre. Why would that do that? Assuming that's the right graph, that is. But obviously it's not the right graph, right what we're wanting to achieve. So again, very important, when you do your caret and then do your exponent, do your right arrow key to get it out of exponent mode. Well, let's take a look at y is equal to x to 1/2. Now normally on calculators, if you got more than a single number or single variable up in your exponent, you had to put parentheses around the exponent. So we'd put parentheses around the 1/2 like that. The TI-Nspire, you do not have to worry about that. And let me show you why. Now what I'm demonstrating here, I'm going to press my tab to go back to the y equals and do my up arrow and delete to clean those out. Oops. We'll choose 3. Don't go back too far. If you go back too far like I did, let me do that one more. It pops up whether you want less than or equal to, less than, equal to, greater than or greater than equal to. If you do that, just choose 3. You want it back to equals. But if I do x to the 1/2 now, if I do x key, caret, it automatically throws it up in exponent mode. So when you do a 1 divided by 2, there's nothing special there. It's already all up in the exponent. And then I press my right arrow key to get out of exponent mode and enter. And that gives us our graph. Now what this one demonstrated is how do you handle it typically when you have more than a single number or single variable up in your exponent? Well, no big deal. It handles it automatically for you in this calculator. You just have to remember, press your right arrow key, get out of exponent mode when you're done with that. Well, let's look at the square root of x. Press tab, go back here, do my up arrow. I'll press delete to clean those out. You can also do clear if you wanted to. The square root, you see, is above the x squared. So I do a control x squared to get square root. I do my x key. Now notice I'm still in the square root at this point. So I want to do a right arrow key to get it out of the square root. And then press enter. And you see we get the same graph. Which is not surprising, because x to the 1/2 is the same as the square root of x. Now the cube root of x. And what I'm really demonstrating here is how do you handle it when you have any number here? 3, 4, 5, 6, any number greater than or equal to 3. That's called your index. Well, if we go back to our y equals, so I'm going to press my tab, up arrow, delete to clean those out. The above the caret, you see it looks like a radical symbol at the end. That end represents where you enter the index. So I do control caret, and my cursor is currently at the index, so I'll put 3 in. And you can press tab, that'll go to the inside the radical, and then you do your x. And I showed you doing the right arrow key to get out of it, and that's always a good way to do it. In some cases, you should be able to do a tab also to get it out of there. But anyway, that's cube root. And then I press enter, and we get that graph there. Now let me show you the fourth root, just to show you another example of that, even though it's the same way. Press my tab, go back here, do my up arrow. Let me try to do a control delete. See how it clears out the entire line? Okay. And now I want to choose the control caret for that. Now put 4 in. Let me try doing a right arrow key. Right arrow key also takes you into there. And then I do my X key, and right arrow key would get you out of the radical. And then enter, and that's our graph. I think next one's absolute value, but let me look. Yep, absolute value. I'm going to try to graph the absolute value of x. Press tab, go back here, up arrow to go back to y1, and press delete a few times. Oops, too many. Okay, absolute value. You see this button right here? See the one that looks like a book? The one right next to it. If you choose that, then you'll see popular options here. And there's absolute value. It's on the second row. So I want a left arrow and down arrow till it's highlighted, and then press enter, and you'll see the absolute value there. Then you put your X key in. To get it out of the absolute value, again press your right arrow key, and now I'm out of the absolute value, and press enter, and that'll give you your absolute value of x. Well, let me take a look at y is equal to x plus 2 over x minus 3. And this is true of any time you have a fraction in your calculator. Anytime you got more than a single number or a single variable on top or bottom of the fraction, the trick to it is put parentheses on top or bottom. So put parentheses on top, parentheses on the bottom. Now if I just had a single x up on top, I wouldn't need parentheses around it. It wouldn't hurt, but I wouldn't need it. Now other than that, we enter it exactly as you see it. So press my tab to go back here, up arrow, delete a few times there. Do a beginning parentheses, and x plus 2. Now notice it was smart enough when I did a beginning parentheses, it went ahead and put a closing parentheses there for us. So you can just press your right arrow key to get out of that parentheses, divided by beginning parentheses, and then x minus 3. And I'll do a right arrow key to get it out of that. Now if I press enter, then that'd be our graph. And you notice it puts the function that we just graphed right there on your display. It's kind of nice. At least it does in the emulator. I got these calculators. I haven't plugged it in quite a while, but I also got these, the handheld that is. I don't know if it does it on that or not. Anyway, that'd be our graph. Now, if I go back to tab, then up arrow. Now here, I've been doing my back, but if I want to change one little item, I can use my arrow keys to put it wherever I want to put it. Let's say instead of x minus 3, I want x minus 5. So I come over to the right of 3, and I'll do my delete. And then I can just type in my new value and press enter. And that changes it. Okay. Let's look at this one with dashes. Got y is equal to dash, square root, dash, x, dash, 3. Now in general, not all calculators care about this, but just in general, always follow the same idea, and then you're always safe no matter what calculator you look at. If you have dashes, most calculators will have two different types of dashes. They have this one right here that's a negative, the one with parentheses on it, and then you have this one over on the side which is a minus. If your dash is at the very beginning of whatever, it's a negative. So this one, since it's the beginning of my problem, would be a negative. This one, since it's the beginning of my square root, will be a negative. Now if your dash is between two things, then it's a minus. Like this one's between the x and the 3, so it's a minus. Now you might argue that this dash here is between the square root and the x, but it goes against our first rule. It says if it's a first and whatever, then it's a negative. Now that's how we're going to type it in. So I'm going to press my tab, up arrow, back to that, now left arrow there. Okay. And we want a negative. So put in my negative first. And then I want to square root. So I'll do control x squared. And then my negative. Then x. And then minus 3. And then to get out of the radical, I press my right arrow key and that gets that out of the square root. And now if I press enter, then that gives us our graph. Okay, now we're going to discover together, because I haven't done this ahead of time, we're going to discover together if the negatives matter, little dashes matter on this particular calculator. So I'm going to go back to my F1, so I'll press tab, up arrow, now left arrow over until my cursor is between the negative and the x, and then I'll do my delete to go back. Instead of a negative, let me change that to a minus. And press enter. And try it again, just make sure it took. Backspace, and put a minus, and then enter. That looks good, looks promising. See how it automatically changed it to a negative? Because it knows it should be a negative. Now if I graph it, if I were to just press enter on it, then we get this right here. Okay. Now let's come here and put our cursor between the minus and the 3. Now let me do it back and change this to a negative and press enter. No error, but look what happened. It gave us the wrong graph. That's frustrating. Now if I press tab and then do an up arrow, it assumed that I wanted negative x times negative 3. So sometimes I'm putting the wrong dash in there. It'll just give you the wrong graph. That can be frustrating come test time and final exam time when you think you've done it perfectly and just gives you you miss every point. Now if I come back there and put in my minus and then press enter, we get back to our original graph. This is why it's important for you to understand which one of these dashes needs to go where. Obviously, it doesn't matter all the time. I put a dash right here, and it interpreted it correctly. This one, it did not guess correctly. Let's look at this one. Y is equal x to the x squared minus 3x plus square root of x power. And we'll just type this in pretty much as exactly as we see it on a TI-Nspire. Now press tab to go back here, up arrow, and delete those. There we go. And we're going to have x, and I'll do a caret for the exponent. And we're in exponent mode, so I can just type all this in directly. I don't need parentheses around it. So I got x squared, so I do my x, then my x squared, minus 3x, so minus 3x, plus square root of x. So I do control x squared to get square root. I'll put the x in. To get it out of the square root, I'll press my right arrow key. To get it out of the exponent, I'll press my right arrow key again. Not that it matters. If you just pressed enter, it would have graphed it. But again, it's good practice to really think of the right arrow key getting you out of whatever you're in on a TI-Nspire. And now if I press enter, it gives me my graph. Let me sketch this down. Looks something like that. Now you learned the basic building blocks here, and some of these you may have wondered, well, that's kind of stupid. I could plot points and come up with this. I was pretty good at that in previous class. Maybe you're the best point plotter there was in the class before this. Everybody else was happy with 3 points in their T-chart. You had to have like 9 or 10. Well, for example, we know what this one looks like. That's a U-shape, the parabola. Or is it? Maybe it comes up like this and goes back down like that. And goes like this. Maybe it's a heart shape. You just didn't plot enough points. Maybe comes up like that and comes back down. Maybe this goes up like this, comes back down. Maybe this comes down at x equals 500. You just didn't plot enough points. If you put 500 points in your t-chart, you would have saw it come back down. Plotting points is the worst way in the world. The only time it really works well is when you already know what the graph looks like. Well, think what I'm saying. You already know what it looks like. Well, a lot of times in college algebra, we don't know what it looks like. The graphing calculator is a step up from that. It still isn't perfect, though. Here's maybe the standard viewing window in a graphing calculator. By looking at this, we think it's a parabola, when actually it's not. It may be the heart shape, maybe coming back down. So it's better than plotting points, but it still has some flaws to it. Now, when we cover the leading coefficient test, you'll see a way to tell if there's more to the graph. But in reality, we trust the standard viewing window a lot in college algebra. And if you go on and take Calc 1 or Business Calc, that's where you learn all the true techniques to find out what the graph really looks like. So you'd find out it's going back down by finding mins and maxes. And that was basic graphing on a TI-Nspire calculator.